Hi, these are notes on determining whether a relation is a function or not a function. So you have this in your modules for the day that we worked on it. We know that a relationship is a set of values, and we know that a function, that the relationship is a function because when the x values do not repeat. So you have this information in your notes, or you can get it off the module, just print it out. But here are some examples of this. So example 1, what we're looking for is if it is a function or not a function. So I want to look at all my x values and I want to say, are they different? They are all different. So A is a function. Okay. Let's look at B. 1, 2, 3, 1, 4. I see 1 and 1 repeat. X repeats. So it is not a function. If x repeats, it's not a function. If x is all different, if x does not repeat, it is a function. So I'm going to look here. Here's my x values right here in a table. This is a function. X does not repeat. I'm going to look here. I see 0 and 0 repeat, so this is not a function. Okay, if I look here, determine each if each relation is a function, we have y equals 5x. It is a linear function because it has no y squareds or x squareds or anything like that. So we know that when we have different x's, 1, 2, and 3, they're all different. That makes it a function. Now on the other page, we saw that there were no y squareds. If you solve this for y and put it into a calculator, it would pass the vertical line test only because it doesn't go below 0. However, our hard and fast rule is no y squareds, because if we had 9 as the y squared, what would happen is we would take the square root of it and we would get two different x's. I mean, we could get 2 of the same x's. So we normally say not a function here. You have to kind of be careful. It's not always that way, but it's so much that way that we will just say no y squareds. Okay, when we have a mapping diagram, as long as the input has one arrow going off of it, it is a function. Because this is like writing -1, 4, 3, 15, 11, 15. We don't care so much that y repeats. We only care if x repeats, so this is a function. This is not a function because you can see that we have 2 lines going off of 2. So this is like 2, -4, 2, -6, 3, -6, and 4, -8. So this is not a function. Okay, vertical line test. So if I drew a vertical line, I hit 2 points. That means that these 2 points share an x. This is 2, 2, and this is 2, 5. So this is not a function. It does not pass the vertical line test. All right, this, however, no matter where I draw the line, it only hits 1 time. So this is a function. It does pass the vertical line test. Okay, enter a Summit High School student's ID number and get a name. Well, a student's ID number is only one ID number per student, right? It's a specific thing. You can't have 2 people with the same ID number. That doesn't make any sense. I couldn't put my ID number in and get my name, and then Miss Wilson has the same ID number and her name comes up too. That doesn't work, right? It's like a social security number, a driver's license number, anything like that. So this would be a function because we want to think about, can you have different x's all the time. Now, the number of passengers in a car based on the age of the driver. Well, lots of drivers are age 16, lots of drivers are aged 45, lots of drivers are aged 30, so that doesn't really work. And even if you turn it around and say, well, let's make passengers in a car the X, you can have lots of cars on the highway or driving around town that only have one passenger or two passengers. So these x's would repeat. So this means it is not a function. And we're done with this one.